Hi folks, and welcome back to the next lecture in our series Mastering Python. For those who are new here, in this channel is all about teaching you how to program. Today we're going to look at modules and packages. How do you create your own modules? How do you create your own packages? Where can you find packages to include in your own workflow? These are really important concepts, especially as your programs start increasing in size. So let's not hang about, open VS Code, your IDE of choice, and let's get coding. A module in Python is simply a file that contains Python code. Think of it as a container for related functions, variables, and even classes. It's essentially just a .py file, nothing more complicated than that. Now, modules help us in two main ways. They allow you to group related code together. For example, you might have a module for math functions, another one for file operations, and so on. And secondly, once you've written a module, you can use it in multiple programs without having to copy and paste the code. Imagine we have a file called mathoperations.py. In this file, we define four functions. We define add, subtract, multiply, and divide. In all fairness, these are not the most exciting functions, but it's for demonstration purposes. With this written, this file is now a module, as simple as that. We can use these functions in another file without having to rewrite them. The simplest way to import a module is using the import keyword, followed by the module name. We've seen this before. This line imports the entire random module. After importing, you can use functions from this module by writing the module name, followed by a dot, and then the function name. For example, here we import random, and then we use the randint function from random, which will generate a random integer between 1 and 10. And then finally we print out this random integer. Sometimes you only need one or two functions from a module, and in this case you can import just those specific items instead of the entire module. For this we use the from import syntax. So here, for example, from math we import square root and pi, which we can then later use in our program. Since we use the from import syntax, we can now use these directly without referencing the module name. This has to do with namespaces, which is something that we'll cover in a future lecture. If a module name is long or conflicts with something else in your code, you can give it a different name, an alias, when you import it. This is especially useful for modules with long names like matplotlib.pyplot, which commonly gets imported as PLT. There's some other conventions as well, as you will see throughout this course. When you import numpy, you usually import it as NP. You can also import all items from a module using the asterisk syntax. So from math, import asterisk. This allows you to use all functions and variables from the math module without the module name prefix. However, this method is generally discouraged because it can lead to naming conflicts if two modules have functions with the same name, and it makes code less readable because it's not quite clear where functions come from anymore. You can also accidentally override variables in your own code. Now, while this method exists, it's better to explicitly import what you need or to use the basic import statement, even if that's a little bit more code to write initially. Now, Python comes with many built-in modules, but there are thousands more that you can install to extend Python's capabilities. As you grow as a programmer, you'll discover many useful modules that can help you write better and more efficient code. You can think of Python as a toolbox. So far, we've been using the basic tools that come right on top. But there's a whole set of specialized tools built into Python that you might not have discovered yet. These are called built-in modules. And Python comes with a vast collection of these pre-written modules called the standard library. It's like having a huge library of books that you can use anytime without having to write them yourself. Before we jump into specifics, let's learn how to explore what's available. The dir function shows you all the names in a specific module. It's like looking at the table of contents, essentially. Here we import math and then we print dir math. And this will print out all of the functions and constants available in the math module. The help function gives you detailed information about a module or a specific function. So here, for example, we look at help from math.squareroot. And this, as you might have guessed it, will show you how to use the square root function. Let's look at some commonly used built-in modules. The math module provides mathematical functions as we've just seen. This is a module that you're going to use a lot, especially if you're working with data. Here, for example, we calculate the square root using the math module, and then we're calculating the sine of 45 degrees after converting it to radian. The random module is another module that will probably make it into most of your programs. It helps generate numbers. Here we generate a random integer between 1 and 10, and we choose a random element from the list of fruits, so apple, banana, or cherry. Finally, the datetime module helps work with dates and times. Here we create a new variable called now, which we set to datetime.datetime.now, and it captures the current date and time. You can also specify a specific date, in this case the birthday, which we then print out. Remember, these modules are just the tip of the iceberg, and we didn't go into much detail. So make sure that you explore these 3 modules and any further ones by looking at their documentation and using the dir and help functions. Python has a rich ecosystem of built-in and third-party modules that can help you tackle almost any programming task, so there's lots to explore. Right, that was modules. Pretty straightforward, right? Well, now let's talk about packages. You can think of packages as folders for your modules, and a package is simply a collection of modules organized in a directory hierarchy. They help us organize related modules into a structure. It's like having folders and subfolders for your files, but for Python code. Here's a simple example of what a package structure might look like. In this structure, my package is the main package. And inside main package, we have module 1 and module 2, which are modules in main package. Subpackage is a package within my package. Now, module 3 and module 4 are modules in this subpackage. The __init__.py files are usually empty, or they contain any kind of code that you want to execute as the module loads, like logging, for example. They tell Python that the directory should be treated as a package. To use modules from this package, you'd import and call them like this. So from my package, import module 1, or from my package.subpackage, import module 3. And then we can use the functions as we've seen before. Let's say you're building a game. You might have a package structure like this. So we have my game, which is the package, and inside we have some modules, characters and items, and some subpackages like levels, utils, which have their own modules inside. Now this structure helps keep your code organized and makes it easier to find and manage different parts of your game. As your projects grow, you'll naturally start to see where packages can help organize your code better. Remember, the goal of packages is to make your code more organized and easier to manage, so don't overcomplicate things if you don't need to. And this brings us to a central part of modern Python, virtual environments. Imagine you're working on multiple Python projects, and each project needs different versions of certain packages. This is where virtual environments come in handy. A virtual environment is like a separate, isolated playground for each of your Python projects. It allows you to keep the packages that you install and any dependencies for different projects separate and organized. Now, to create a new virtual environment, we use the simple command python-m venv and then the name of your environment. You can name the environment whatever you want. In this case, we'll name it myenv. So python-m venv myenv. This creates a new virtual environment called myenv. To activate the virtual environment, on Windows, you type myenv/scripts/activate. On macOS and Linux, type source myenv/bin/activate. You'll see the name of your virtual environment in your command prompt indicating it's active. Now, any packages you install will only be available in this environment. And to deactivate the virtual environment, you simply type deactivate. It's really good practice to create new virtual environments for each new Python project you start. This not only keeps your project clean, but it also avoids conflicts between package versions. So where do you get new packages to install into your virtual environments? PyPI is a great place to start. PyPI is like a massive online library of Python packages. It's where developers share their code for others to use and where you can find packages to enhance your Python projects. Simply head over to pypi.org to search for packages by name or keyword. Once you've found a package that you want to use, you can install it using pip. That's Python's package installer. And here's how it works. You'd write pip install and then the name of the package. Now, if you're on Mac or Linux, you might have to write pip3, but the rest of the syntax is the same. So in your case, it would be pip3 install and then the name of the package. For example, to install the popular requests library, we would go pip or pip3 install requests. Once you've installed your packages, you can import them and use them in your Python code as we've seen earlier. So here, for example, we import requests, then we get a request from my website codewithgunnar.com, save it as a response, and then we check whether the status is good, whether we got a good response back from requests, and we print it out. As you become more advanced, you might want to share your own code on PyPI. Now, this involves creating a distribution package and using tools like Twine to upload it. And we won't go into this detail here, but it's definitely something to look forward to as you progress. And there you have it, modules and packages. Pretty straightforward like all the topics so far in Python. Next time, we're going to look at error handling, what to do when things don't quite go to plan, how you can debug your own code before then jumping into object-oriented programming. So if you found this video helpful, don't forget to like and subscribe, and I'll see you in the next lecture. Until then, happy coding.